Have you ever asked an AI for help with a really complex problem, only to get back an answer that's just completely useless? Well, today, we are going to dive into some incredible research that shows how a pretty simple change in approach, using a team of AIs instead of just one, can lead to a mind-blowing 140 times improvement in getting the right answer. Let's get into it.
And hey, real quick, if you're into explainers that get right to the point like this one, do me a solid and hit that subscribe button. It makes a huge difference. Thanks.
All right, let's just start with a number that is kind of staggering. 98.3%. According to a recent study, that's how often a single AI agent, when asked to solve a tough operational problem, gives back a recommendation that's vague and totally unusable. I mean, think about that. It fails almost every single time.
And this gets to a feeling I know a lot of you have had. You're in a high-stakes situation, you need a specific fix, and your super powerful AI tool basically just shrugs. So, why? Why does this keep happening? Well, it turns out we might have been asking our AIs the wrong way all along.
The heart of the issue is what the research paper calls the single-agent problem. We're basically handing a single AI this huge, complicated task with multiple steps and just expecting it to spit out a perfect answer.
I mean, think about it from the AI's perspective. You're asking it to diagnose a problem, come up with a plan to fix it, and figure out all the risks, all in one go. It's just too much. So it defaults to the safest, most generic advice it can think of, like investigate recent changes. Super helpful, right? This isn't really a failure of the AI model, it's a failure of the architecture we're using.
Okay, so if giving the whole job to one overworked generalist is the problem, what's the solution? Well, it's what you do in the real world. You build a team of specialists. And that's the whole idea behind multi-agent orchestration.
So instead of one massive request, the problem gets broken down into a workflow. First, you send the problem to a diagnosis agent. Its only job is to figure out the root cause. That's it. Then its findings get passed to a planning agent, whose only job is to create specific, actionable steps to fix it. And finally, that plan goes to a risk assessment agent. Each one is an expert, doing just one thing and doing it really, really well.
Now, this is a super important point. When we say agent, we're not talking about 3 different expensive AI models. It's the exact same model. You're just calling it 3 separate times with 3 very focused, specialized prompts. The magic here isn't in the model. It's in the method. It's all about the architecture.
So, does this whole team of specialists thing actually work in practice?
Oh yeah.
The results are, and I'm not exaggerating, absolutely incredible. Let's look at just how big the performance gap is.
And this slide just says it all, doesn't it? On the left, you get that vague, go look into it suggestion. On the right, the multi-agent system gives you a precise command you can literally copy and paste to fix the problem. One creates more work for you, the other one just solves it.
And look at this chart. The single agent gave a truly actionable answer less than 2% of the time. The multi-agent system, 100%. Every single time. Across all 116 tests, it produced a useful answer. That's not just an improvement. That's the difference between a fun toy and a professional tool you can actually rely on.
That incredible reliability comes from being specific. The answers from the multi-agent system were 80 times more specific. It didn't just say roll back the service. It said roll back this specific service to this exact version using this exact command.
And here it is, the headline number. The solutions from the multi-agent system were 140 times more likely to be the correct fix. Because being specific is great, but being specifically right is what actually saves you during a crisis.
So the most critical difference, especially for professional use, is consistency. The single agent is basically a roll of the dice. You never know what you're going to get. But the multi-agent system, it achieved what's called deterministic quality. 0 change in quality. It gave the same high-quality, correct answer every single time. You can actually build a dependable process on top of that.
So what's really going on under the hood here? Why does this team approach create such a massive boost in performance? It really comes down to a few smart architectural advantages.
It boils down to a few key things. First, task specialization, which we've been talking about. Then there's implicit fault tolerance, which basically means if one agent messes up, it doesn't sink the whole ship. And finally, it's structured by design, so the output you get is naturally logical. Here's the diagnosis, here's the plan, and here are the risks.
Now, of course, this isn't a magic bullet. As developers out in the real world have pointed out, managing a bunch of different agents can create its own headaches, especially when you have to figure out why something went wrong. It's an engineering trade-off. But, as this research shows, it's a trade-off that is clearly worth it for that incredible leap in quality.
And that leap in quality? It translates directly into the two things every business cares about most: saving time and saving money. The study estimates that for a typical team, you save over 100 hours of engineering time a year just by getting rid of the time wasted trying to figure out what a vague AI suggestion even means. That's more than 2 full work weeks back in your team's pocket. And the return on investment is just crystal clear. We're talking about an estimated $20,000 a year in saved labor costs, another $50,000 a year in reduced business impact because you're fixing problems way faster, and that's not even counting the human benefits, like way less stress for your on-call engineers.
This really gets to the heart of it. Both systems took about 40 seconds to give an answer. But speed without quality is just a fast way to get a useless response. The goal isn't just to be fast. The goal is a correct, actionable, and, most importantly, a reliable answer every single time. And that leaves us with a pretty big question to think about. In an industry that's obsessed with building bigger and bigger AI models, this research suggests that maybe the biggest wins aren't in the model itself, but in the architecture around it. Are we so focused on building a smarter AI that we're forgetting to build smarter systems? Something to chew on. Thanks for tuning in.